When they're asking for the probability, guys, you don't even have to write probability of prime. I just usually do that so that I know what the question was. But if you just write a half as your answer, that's fine. Don't stress about that. Yeah. But guys, what you don't have to do, you don't have to write 3/6. You can go straight to a half if you know that it's a half, but you can't leave it as 3/6. Okay, so what you have to have is 1/2. That's where the mark will be. For number 2, again here I wrote n, which stands for number. All right, you didn't have to. You could have just said 13. That's fine. But I just wanted to show you the proper notation, which I think was in that note that you had to go through yesterday, was it? Use the n with brackets in that note.
Probably was.
Fine. You don't have to write it. It's just if they ask you, they just say in the question, what is n of half? You need to know they're talking about the number of halves, right? Halves. Okay, and then there in C, I was lazy. I didn't want to write the probability of every time, but like I said, you don't have to, so you can just draw those.
Now the probability get much harder than it does than what we're doing right now.
Yeah.
You don't have to.
So it's more complicated but not harder.
Okay, can I move on to the next exercise, guys?
Yes.
Okay, there's number 1. Sorry, we just go back on. Yes. Now, guys, in the note that you had to go through yesterday, there was quite a lot of talk about and or and what the difference is. I'll go back to that note quickly just so that you can maybe write it down if you didn't write it down yesterday, because it is quite important. But in the note, what they're talking about probability identity and the or rule and all sorts of stuff. That's when you have 2 things happening. All right, so if you are drawing, for example, 2 cards and they're asking what's the probability of it being a red and a jack, right? In this case, when I'm reading through the question, it's just saying a card is drawn at random, so there's 1 card being drawn. So when they're saying in C, what's the probability of that 1 card being red and jack? How many red jacks are there, guys? 2, isn't it? 2, right? So that's why I said here 2/52, because 2 of the 52 cards are red jacks. Okay, again, you don't even have to write that first, but you do have to write the simplified version. Okay, so 1/26 is your final answer. If we're looking at the next one, red or jack, what is the probability that when you draw a card that is either a red card or a jack? All right, now there are 26 red cards, do we agree? And then there are 2 other jacks that aren't red. Yes, so that's why I say 28. Okay. All of those rules that we're going to write down just now are not for when it's just 1 thing being drawn. And number 2. No, one of the 10. One of the 10. You see. So, guys, if they're now saying green and blue, do you agree that when you're drawing 1 marble, it can't be green and blue at the same time?
It's an A and R.
It's again 1. Yeah, but not in this case.
I thought it was like you take 1.
Okay, fine on this one. Okay. Okay, number 3. All right, so this was now about the number cards from 1 to 10. Again, guys, it's just one card that's being drawn. A card is selected at random. So every time you need to ask yourself, how many cards are there where it's even and it's not divisible at the test? What? Is something wrong? I'm not. Maybe not, something wrong. It's very possible. Guys, facial expressions and making it out myself. I know. Even and not divisible by 3. Okay, so there are 5 even numbers, and then 4 of them are not divisible by 3.
6 to only 1.
6 is the only one. Oh, it had to. So 2, 4, 8, and 10.
Yeah, I did
I
separate.
Yeah.
Again, you would do that if it was 2 being wrong.
Did they send her again a single?
Yeah.
That's so for English. I think it's on good.
Okay, I'll refine that. All right, new notes. Oh, wait. Let's go back to this. Guys, if you didn't write this down yesterday, I would like you just to make a heading and an all statement. So basically, you're just going to write down what I've highlighted, okay? Because I know that this notebook on Google Classroom is getting printed for you. Yeah, I think it was.
Yeah, I was really good in physics. The oral work was online, and then no, it was like no. No, our teacher was activistic. But I'll get it.
Okay, have you written that heading, please? I just want to show you there it says an and statement. Okay, so that's another one. Yeah, I'm not sure. So guys, you just need to write down that first line of that sentence, and then you're going to write down the actual rule. Okay, that's the actual calculation that we do. And we're just going to look at some examples. You can write down that example as well if you want to. You're just saying there's a probability of drawing an ace from one pack of cards and a jack from another pack of cards. If they're saying you have 2 packs of cards and you're drawing a card from each, what's the probability of drawing an ace and a jack? All right, so then whenever you see an and, you need to think on this time thing. Why is it one over 50? Oh, sugar that's like 4? Yeah. Okay, let's just fix that one. That's odd. Okay, so this is supposed to be 4. What?
The statement. Yeah, maybe.
Yeah.
It is chocolate.
So it's the probability of drawing an ace and then a jack of hearts from another pack of cards.
Just hold those to the left. What do we have? That's up
Just
to
that first line is an and statement, yeah. I'm just gonna move down a bit so that you can see the next one. The next one is an or statement, so it says to calculate the probability of either one outcome or another outcome happening. We use an or statement, or you can just say is an or statement, so that it's the same as the one above. And then what you can do is we can just take the two separate probabilities and add them together. Now, sub-exams. No, and George. Very common. Yes. So that is when there's an overlap. Okay, so guys, I'll show you now when I show you the next one. But this or statement formula works when there's no overlap between the two outcomes. So I'll show you now when we can actually compare the two. Then you can just add them. Okay, so the example that they have there is the probability of getting a 5 or a 6 when you're throwing a die. Now guys, I think most of you wouldn't actually use this formula. You would just think a 5 or a 6, that's 2 of the 6 options, right? But they're just showing you that you can use this formula. You can split it up into what's the probability of getting a 5? 1 over 6. What's the probability of getting 6? Also 1 over 6. So if you add those two together, you are also going to get 2 over 6, which is not good. But I think yeah, it's probably just easier to just think, okay, a 5 or a 6, that's 2 of the 6 options. So you don't have to use this formula, but you can if you want to. But then sometimes the two outcomes overlap. And we saw that now, if I'm just thinking back to the one that we marked, where it was asking for a red card or a jack. Right? Do you guys remember? Then we said, okay, there are 26 red cards. They're actually 4 jacks. Right? But they're already 2 of the 4 jacks are already red. So we kind of minus those 2 off. So what you do then is when 2 events overlap, we add the 2 probabilities and subtract the overlapping bits. So we call that the probability identity. So that's also an or statement, but because the 2 events are now overlapping, you have to subtract the part that's overlapping. So that is where the probability of A or B is probability of A plus the probability of B minus the AND part. So minus those 2 jacks that are red. And that were already a part of the red part. I'll show you one way now.
and we wouldn't have the one.
Let's see, I think this question, yeah, is saying less than 3. That example. Oh. So the example that we're asking you there, that we're showing, determine the probability of getting an even number or a number less than 3, which is L, when throwing a die. So what they've done, just so that you can see that there is an overlap, is they've listed those two outcomes, right? Even numbers, 2, 4, 6. The numbers less than 3 would be 1 and 2. So we can all see that 2 is a part of both of those sets, right? 2 is in both outcomes. So guys, if you're now taking E, that's 3 of them, and then you're adding L, that's 2 of them. You counted the 2 twice, right? So you do have to minus that 2, which is the overlapping. That's where that formula comes from.
Then now there's a student document. Then how do you identify the things that overlap?
It depends. If it's more than one thing, you can just count how many there are that overlap. But sometimes you'll just be able to tell from the actual question. So if you're thinking back to that red jack, red card or jacks, there are 26 red cards, but 2 of them are jacks. And then there's 4 jacks. You've already included 2, so you would minus 1 to 2. Okay, so this is yes. Alright, when you are done copying this down, you can write a new heading, name diagram. You guys didn't do Venn diagrams last year, right? Yeah, like a new heading. Yeah, tree diagram.
Oh, no, like it.
You've definitely seen Venn diagrams before, and they've not.
So I would do like the P and the P and the last and everything. Do we put what the overlap is instead of like we did there with the 2. Instead of going E,
So you minus how many are in the overlap. So you see the overlap is 2, but the minus is 1. That was one number that was in the overlap. Yeah. So you minusing the probability of that overlapping.
then I don't know, but what I'm saying is that do we always put the overlap in, or do we just like add, you know, like we did the original,
Oh, I see what you're saying. I didn't even notice that. What notationally? Just check. Oh yeah. Sorry guys, I wasn't paying attention. Here they've written minus the probability of 2, but you could also just write B and L. Is that your question? Yeah. Yeah, I don't know why they probably typo that's okay.
How do we spell the ever?
Venn. Venn diagrams. Okay, are we ready, guys? There you go. Just copy that down. Venn diagram.
I will give it one.
I'll take no.
Oh, yeah. Oh, stupid.
Or is the Venn diagram the sort of circle when they overlap sometimes? Oh yeah, they do.
Somebody,
Sounds scary.
I'd like to have a fun ever.
Yeah, the number smaller than 3 and the number larger than 3 is 3 in that equation as well.
So it has to be in the box. But it has to be in the box.
So would it be in the process?
All right, guys, but it's not. Okay, please add that there at the bottom. We're gonna pull this diagram in. Okay, guys, I would like you to notice that there's an S there. What do we think that stands for? So guys, if we are rolling a die, what is the sample space? What are the possible outcomes? 1 all the way to 6, right? So what this means is that in this box, I need to write all 6 of those numbers, okay? But some of them are going to have to go in the circles. Some of them not. So A, the circle A represents the outcome numbers smaller than 3. Now, which numbers, if you're rolling a die, are smaller than 3? 1 and 2. So just put 1 and 2 wherever in that circle. Okay, those two numbers fall into event A or outcome A. And what about numbers larger than 3? Those numbers will go into circle B. So those would be 4, 5, and 6. Have I now included all of the numbers in the sample space in my Venn diagram? No, 3 is missing, right? So guys, 3 can't go into A or B, but 3 is still a part of my sample space. So anywhere in that box outside of those 2 circles, you have to put 3. It can be anywhere. It could be there in the top corner, wherever. All right, up to you. Create. All right.
But having load shedding for 10 months is a standard. So then I have to literally. So what is
All right, thank you.
Yeah.
Okay, that is just some terminology that you need to know, please. Mutually exclusive. Thank you. Events or outcomes that cannot occur at the same time. So when you're rolling that die, it can't possibly land on a number that's larger than 3 and smaller than 3 at the same time. Okay. So you'll see that when you have mutually exclusive events, the circles will never overlap. The circles will always be separate. Okay, so that's one term that you need to know. That's new. Meaning the other term is exhaustive. Now, in this case, A and B are not exhaustive, but I'm just going to explain what that means. And so exhaustive events are just when all of the outcomes are in those 2 circles. In this case, because 3 doesn't fall into either of them, they are not exhaustive. Okay, we are going to do an example now where information is given and we have to fill in a bit of a more complicated Venn diagram. And guys, Venn diagrams can be filled in different ways. In this case, we put the actual numbers in the box and in the circles. But sometimes we're going to put like number of people in there. Okay, we're not going to list specific items. We're just going to list totals. Okay. I'm just going to write example.
Would they not? No, but it's all very much about.
There you go.
Yeah.
Hey guys, that helping us out. What you can do, guys, since there is an overlap, do we agree? Some people want milk and bread, right? You can draw your Venn diagram so long, but now because there's an overlap, the two circles will also overlap. Okay, so you're not going to draw the two separate circles like we did before. I'm going to draw two circles that are overlapping. Yeah. Okay, I would probably just call the one circle M for milk and the other one B for bread. Usually in a test exam, they'll tell you which letters to use.
Can't stay.
All right, now guys, something that I didn't do. Something that I didn't do for the previous example because it wasn't really necessary. I didn't write how many items are in the like full output. Let me just check. Is this lines too? Yeah, it is, eh? It's better. Okay. Guys, I would like you, because they're telling us that they asked 150 people, right? Just somewhere on the outside of that box, I normally put it on the top right hand corner, but it doesn't matter. Just put a 150 there so that you know that all the numbers inside this box must add up to 150, right? Because 150 people were questioned. Okay, now I suggest that you start by filling in the overlap. Because if we're looking at these numbers, right? They're saying 125 people bought milk, 85 bought bread, but 70 bought both. Now guys, if you're adding these numbers together, we're going to get more than 150, right? Which means that these 70 people, they are already included in these two totals. All right. So you're going to want to fill that 70 in first. And now the entire milk circle must include 125 people. I can't put a 125 there, guys, because how many people do I then have in that circle? 195. Okay, which is wrong. So you have to do the overlap first and then work your way out. So what must I put here in the end part? If it's 125, I already have 70, I need to put 55. Okay. And then we need to do the same thing with the bread. So it was 85 people that bought bread. There are already 70 people in the bread circle. I just need to put in the other 15. Okay. Now guys, if you add these numbers together, what do you get? 150. But there were 150 people questioned, which means the 10 of them didn't buy either. Okay. So the 10 must go somewhere on the outside of the two circles, but still in the box. Now guys, take note, they didn't mention that at all. All right. They were trying to not really trick you, but you do have to think about this, even if they don't mention that there were people that didn't buy either. Okay, sometimes you've gone to the shop and you haven't bought more corporates. Okay, same. So okay, that's it, guys. That's filled in. Okay, B. Okay, guys, for this one, we need to look at the Venn diagram. Okay. Okay. So they're asking us for the probability that a random chosen customer bought bread but not milk. So they bought bread, so we need to look at the bread circle. But remember, 70 of these people bought milk as well. So how many people bought bread but not milk? No, it's 15. Okay. Out of how many people? That's the question. 150. Okay. So again, you don't have to write P and bracket bread but not milk. You can just write the answer if you want. So 15 over 150, is this simplified? What is the simplest form there? Okay, I'm just gonna do one more. 1, 2. Nope. Nope. Okay, how many people? 10. Alright. What did you say? Okay, any questions? All fine, okay. Homework. There's still a yes. No. Yeah, you're just quickly write this down, you know. Okay, and I'm just gonna put a little smiley face over number 12.
Why is it horrible? Why is it always number 12? Like in every exercise, it's constantly number 12. That's one exercise.
Okay, get going, please. You have 10 minutes. You can finish in that time.